Breaking news: widespread disruptions reported across financial and critical systems.
Investigators confirm malicious code was introduced long before deployment.
In response, new federal policies and executive orders are tightening software security requirements.
The breach didn't start with an attack. It started within the code itself. Most organizations still rely on binary-level code signing, waiting until late in the development cycle to establish trust. In today's threat landscape, that approach leaves dangerous blind spots. Organizations cannot prove who touched the code, when it changed, or under what authority. As recent incidents have shown, the software supply chain has become one of the most targeted attack vectors. The response has been clear. Federal mandates and frameworks, including Executive Order 14028, OMB M2218, and NIST Secure Software Development Framework, now require provable provenance, stronger code signing, and full lifecycle accountability. Because software that cannot be fully trusted cannot be safely deployed. CodeLocker is ahead of the game by uniquely resolving these challenges. Built by Zeva, with over 2 decades of experience in federal cryptography and public key infrastructure innovation, CodeLocker is purpose-built for organizations that must meet modern and future security mandates without slowing delivery. CodeLocker delivers centralized, commit-level, identity-centric code signing. Let's see how CodeLocker works in practice. Meet Peter, a developer working on a project protected by CodeLocker. CodeLocker is integrated directly into Peter's development environment. Peter updates the code and commits his changes. Before the commit is finalized, CodeLocker prompts Peter to authenticate. The commit is cryptographically signed and bound to Peter's verified identity. This establishes provable authorship and non-repudiation at the moment code is written. If an unauthorized user attempts to introduce code into the same repository, the code may look valid, but the identity is not. When the commit is pushed, CodeLocker enforces policy automatically. Commit rejected, unverified identity, signature required. Without a verified identity and cryptographic signature, the code never enters the system. Threats are stopped at the source, before they reach the pipeline. With CodeLocker, trust is enforced at the earliest possible moment. Eric is responsible for the build pipeline. CodeLocker is embedded directly into the build process. Eric initiates the build. As the pipeline runs, CodeLocker signs all outputs. This includes binaries and the software bill of materials. Every artifact is now verifiable and traceable back to the original commit. Beth is the program security lead. Before release, Beth reviews CodeLocker's dashboards and audit reports. She can see who signed each commit, when it was built, and how it moved through the pipeline. This provides complete auditability, from source to deployment. Across development, build, and audit, CodeLocker enforces trust automatically. Developers keep moving fast. Security teams gain confidence. Adheres to trust, integrity, and authenticity, as outlined in NIST 800-53 Revision 5, and Software Fast Track (SWIFT) requirements for software validation. CodeLocker changes the equation. CodeLocker positions organizations for a future where supply chain visibility, trust, and code integrity define the winners.